All right, today's lesson should look very familiar to you. Let me flip the book here and get to my page. And we've actually done a little bit of this already this year, and it's Pythagorean Theorem. Do you remember that? Pythagorean Theorem. But this is where they officially teach it to you in geometry, right? We've already talked about it before. We discussed it. They've had problems where you had to know Pythagorean Theorem, I believe, to be able to solve for it, because you learned it back in Algebra 1, right? I don't know if you learned it before then or not. I don't know if they teach that in pre-algebra. Seventh grade you learned it? Okay, good. Yeah, it's a very, very, very famous thing that we do in math. Very famous, yes. So here it is. You remember this? A squared plus b squared equals c squared. Well, what in the world does that mean? Okay, it's easy to remember. It's just as easy as ABC, right? That's how I always say it. It's as easy as ABC. A squared plus b squared equals c squared. Now, you can only use this. What's this whole chapter about? Do you remember what the whole entire chapter is about? Right triangles, okay? You can only use this with a right triangle. This does not work with any other triangle, okay? Only works with right triangles, all right? Did I put enough lines under there? Okay, I did that to emphasize that you can only use this stuff with right triangles. Well, what do these letters represent? What does the A and the B represent? They represent the legs of the right triangle. Okay, so look at this right triangle right here. Which ones are the legs? That would be a leg, and that would be a leg. All right. What does the C represent? The hypotenuse. Good. Okay, so the C, I'll just put HYP. Is that all right? So the C represents the hypotenuse. The C is always the hypotenuse. The A and the B, does it matter which leg the A and the B stands for? No, it doesn't make any difference, okay? As long as A is one leg and B is the other leg, it doesn't matter which one's A and B. But the C definitely makes a huge difference, okay? C is the hypotenuse, and that's the one that you really need to understand. So, for instance, let's do a little example here. Let's get rid of these letters and actually put some real numbers in here. Let's say I put a 3 here and a 4 here. This is about the easiest one that you could possibly do. That's why I started with this. And you wanted to solve for the hypotenuse. You wanted to solve for C. Well, look what you have. You've got 3 sides of a right triangle. So whenever they give you 2 sides of a right triangle and they want you to find the third side of a right triangle, you can always use the Pythagorean theorem. Okay, so that's what we're going to do right here. We're going to use the Pythagorean theorem. They give me 2 sides of a right triangle. I got to find the third so I can use it. Remember what it says? A squared plus b squared equals c squared. I'll put it there so we remember. The 3, put that in for the a, so it's 3 squared. The 4 goes in for the b, so that's 4 squared. What's the only thing we don't know? We don't know the c, do we? So here's the math on how we do this. Everybody understand how we set it up? Pretty basic. As long as you know which letters stand for what, just plug and chug, right? Plug it into the formula, and now we work it out. What's 3 squared? It's 9. 4 squared? 16. And that equals c squared. Let's add these up. 9 plus 16 is 25 equals c squared. Now we've done this the whole last lesson. You got to get c by itself, so we square root it. Remember that? And this comes out nice and pretty, doesn't it? Square root of 25 comes out nice, perfect number. This is a perfect square. We call it a perfect square when you can take the square root of it and it comes out to a nice even number. All right, and that comes out to 5. And so that's what that is right there. C is equal to 5. Later on in the chapter, we'll talk about some special triangles, special right triangles. And this is one of them. It's called a 3, 4, 5 right triangle. So you'll be taking the SATs if you haven't already. And they're going to give you stuff like this. Watch. They're going to say, this is 6, this is 8, and then solve for that. You could do Pythagorean theorem. You could do what? 6 squared plus 8 squared equals x squared. You could do that and do all the math. But if you recognize this special right triangle, if you have a 3 and a 4, the hypotenuse is going to be 5. Well, look at this. This 6 right here is twice as big as a 3, isn't it? This 8 right here is twice as big as a 4. So guess what x is going to be? It's going to be twice as big as a 5. So what's x going to be? 10, without hardly doing any work at all. When you take the SAT, it's a time test. You have to finish in a certain amount of time. It's so much nicer to recognize, and I can almost promise you that on the SAT you're going to see a couple problems where it'll be like a special one. It'll be one of these special triangles, like a 3, 4, 5. There's other ones too. We'll talk about those later. They call them Pythagorean triples because they come out to nice, perfect whole numbers. Not all right triangles come out that way, do they? You saw in that last lesson, a lot of stuff comes out square root of stuff, right? Caitlin asked, why does that one come out even and that one comes out to a square root? Well, because that's just the way it is, okay? These all come, that came out to a square root. That was the square root of 100. It just happens that it simplified to a nice whole number, okay? They're not always going to look this pretty. They're going to look a little ugly sometimes with a bunch of square roots all over the place. But that's what we call a 3, 4, 5 triangle. So 6, 8, 10. Does everybody understand that? So 3, 4, 5 is very, very important to us because it just makes things a lot easier. You didn't have to know about a 3, 4, 5, but that is very nice. All right, well, let's do another triangle. And I'm just going to make some numbers up just to make them kind of weird. All right, just to show that they don't always come out nice and perfect. Okay, what if this was 5? Okay, let's go 7. Let's say this was 7 and this was like 2. Yeah, 3. I like 3 better. Let's use 3. Okay, so let's take a look at that. What if you wanted to solve for that side right there? Well, it's a right triangle. You have to know it's a right triangle, and it is. And I know 2 sides, so I'm going to use Pythagorean Theorem. So let's do this. You know how I've always said a squared plus b squared equals c squared? Sometimes you might want to write it like this, and I'm going to show you why in a second. C squared equals a squared plus b squared. Do you mind if I do that? That's not that big of a deal, is it? We just kind of went out of alphabetical order, but we still put the c by itself. It's still the hypotenuse. These are still the 2 legs. So let's take a look at this. What am I going to put in for the c? Whatever the hypotenuse is. What's the hypotenuse on this right triangle? It's x. So I'm going to go x squared equals what? 7 squared plus 3 squared. It doesn't matter which, if you put the 3 in here or the 7 in here, you're still going to add them up anyway. Let's see what we get. X squared is what? What's that? 49 plus 9. And that's what? 58. So x is just the square root of 58. Just leave it like that. There's no reason to turn it into a decimal. You just leave it just like that. You okay with that? All right. So look, even though these 2 sides are nice whole numbers, my hypotenuse came out to an ugly square root, which is fine. All right. I don't mind that at all. That's really not that big of a deal to have a square root. What if they did this? What if they give you a right triangle? Again, I'm just making numbers up here. Let's say that that's 13, and let's say that's 5, and let's call that one x. What about that? What are we going to do here? For some reason, I always like the x to go first, so I'm going to do this. I'm going to square both of the legs, right? So x squared plus what? 5 squared. And what's that going to equal? 13 squared. The one that goes by itself, the one that's not being added to the other stuff, that's always the hypotenuse. Everybody see that? So this is your hypotenuse. Now, in the problems that we did earlier, we always solve for the hypotenuse. We solve for c. This time we're solving for one of the legs. So the math is just a little bit different. Not a whole lot, but a little bit. So let's do this. X squared plus, what's 5 squared? 25. 13 squared, that's 169, I believe. And then, what do we do here to get x by itself? Well, yeah, this time we subtracted 25. The math is a little bit different at this point, but it's stuff that you've done before. Minus 25, and watch this. This is x squared. That cancels, and what's that? That's 144. That looks familiar, doesn't it? If I take the square root of 144, can you do that in your head? It's 12, isn't it? It's just one of your multiplication tables. So check it out. I got all 3 of them to come out to a nice whole number, didn't I? Everybody see that? So this is one of our other special type of triangles. We'll learn in another lesson. We had 3, 4, 5. What do you think we'll call this one? 5, 12, 13. There's quite a few special triangles. It's hard to memorize them all, but this is one that shows up every once in a while. So instead of going through all this stuff, now that we recognize 5, 12, 13, instead of going through all that mess right there, if you had a standardized test, and they said this is 5 and this is 13, you had to find this, hopefully you'll have that in your mind and you're like, oh yeah, I remember a 5 and a 13. What was it? Oh yeah, it was 5, 12, 13, and boom, you can do it just like that. All right? And that's kind of nice when you can do that. Let's say you didn't remember it. Let's say you didn't remember that special triangle. Well, you could always do Pythagorean Theorem and find it anyway, couldn't you? All right? All right. This is all with right triangles, isn't it? So let's do this real quick. Almost finished with this stuff. Actually, it was this lesson where they did the Pythagorean triples. Look at the bottom of page 542. I'm glad I mentioned it because I just flipped the page. Look at the bottom of 542. There's a whole chart, and they're called common Pythagorean triples. Now, there's more than these, but these are the ones that show up quite a bit. And some show up more than others. Look at it. You got 3, 4, 5. The one we just finished doing, which is 5, 12, 13. There's a couple more they give you. 8, 15, 17. And they give you 7, 24, 25. So it's kind of nice to recognize these. If you can recognize them, then you don't have to really do a whole lot of math. For instance, watch this. What if I said this was 8 and this was 17 and I asked you to solve for that? Without doing a whole bunch of Pythagorean Theorem stuff, if you have that memorized, you're like, oh, 8 what, 17? Yeah, 8, 15, 17. Boom, I'm done. Isn't that nice? Okay. So those are your common Pythagorean triples. Do you have to memorize them? No, you don't have to. But I tell you what, it sure makes life easier if you do know a few of these. This is definitely the one. 3, 4, 5 shows up more than any of them. That's really, really important. All right, let me do one more thing. We can decide if we have a, let me find an example here. Watch this. What if I have lengths 7, 14, and 16? Can I determine if that's a right triangle or not? How would I know if it's a right triangle? Well, if it fits into this, then it's going to be a right triangle. All right? So what number am I going to put in for C? 16, because if it's a right triangle, 16 must be the hypotenuse, right? So let's try it. Put a 16 and square it. Let's take the other two and square them. So 7 squared plus what? 14 squared. Dustin, give me some numbers. What's 16 squared?
4.
16 squared. What?
4.
No, it's not. 16 squared.
Squared.
16 squared. Don't leave yet. Hold on just a second.
256.
256. 7 squared is 49. What's 14 squared?
14
Quick.
squared is 196.
196. Do 196 plus 49. Quick. 196 plus 49. Okay, now watch this. I want you to see this real quick because I have to. This is going to be on the worksheet. 256. Is it equal to 245? No, it's what? It's bigger. So if it's bigger, it's an obtuse triangle. What if this was smaller? What kind of triangle do you think it would be? It would be an acute triangle. If it was equal, it would be a what? It'd be a right triangle. All right, that should be enough, and I'll give you the worksheet before you go.